Hi and welcome to another carpenter tutoring tutorial. I'm Amy and today we are going to be talking about factoring quadratic equations when the first coefficient or the a term of that quadratic equation is 1. Our goal today is to get comfortable with this process so that you can work smarter, not harder, in any factoring problems you might have to do of this format. Right now, if you didn't watch the general factoring introduction video yet, you might be questioning, okay, A what? Where is A coming in? As a quick reminder, this comes from the standard format of quadratic equations, which is ax squared plus bx plus c equals 0, where a and b are coefficients and c is a constant. So we're talking about situations here where a is equal to 1. Now, typically when a is equal to 1, we don't write a 1 in front of the x squared term. Because x squared times 1 is just x squared, we'll see it on its own. So for our sample question today, we're going to be taking a look at the quadratic equation x squared plus 3x plus 2 equals 0. All right, now remember, there are a couple things we have to do before we can jump right into factoring. The first thing we have to do is check that our equation is set equal to 0. This one is, so we know we're good to continue. The second thing we have to do is make sure that we have taken out any greatest common factor. As I look at my coefficients and my constant, I see that I don't have a greatest common factor between 1, 3, and 2, so I don't have any extra work to do there. That means I'm ready to jump into factoring. Now, the method that we're going to use for factoring this equation has a lot of different names. I call it magic numbers, but you may hear it called something else. But what magic numbers says is we are looking for two numbers, and I like to refer to them as W and Z before I know what their values are. These two magic numbers should multiply to the same thing as a times c in our equation, and they should add to the same thing as b, our middle term. So in our equation above, a and c are equal to 1 and 2 respectively. So we're looking for numbers that multiply to 2, but add to our middle coefficient, which is 3 in this case. So two numbers that multiply to 2 but add to 3. Well, I can think about 1 times 2, which equals 2, and 1 plus 2 equals 3, so we've already found our magic numbers. That means W and Z have to be 1 and 2. An important note here is that the order does not matter. If I said that W and Z were 2 and 1, we'd still be on the right track and good to go. Now that we have our magic numbers, we have to turn them into our factors. So in order to do that, go to the first term of your original quadratic equation. In this case, we had an x squared. We're going to take the square root of that value and put it into the beginning of each factor. So the square root of x squared is x. That means that I'll start each of my factors with x. This is important because if we started with something like an x to the 4th instead, I'd still have to follow the same process of taking the square root of that first term, which would be x squared. That would mean we would start each factor with x squared and not just x. All right, so that's where the first term of each factor comes from. Look to your first term of the quadratic equation, just the variable portion of it, and take its square root. Here is where we use our magic numbers. So the magic numbers come into play by occupying the second space in each factor. So I can have 1 and 2. In between the first and second term of each factor, we need to have either addition or subtraction. You determine which one you use based on the sign of your magic number. So our magic number 1 was a positive. That means we are going to use addition between x and 1. And our magic number 2 was also positive. That means that we will use addition between x and 2. An important note here is that this is still all equal to 0. Now we have our quadratic equation turned into factored form. We see that we have two factors of x plus 1 and x plus 2. Remember that the parentheses around each of these means they're being multiplied together, and that's going to be important to remember if we are trying to solve. All right, but our goal in this video was just to factor this quadratic equation. If you'd like to continue to the next step of solving, please take a look at my video on solving factored form equations. If you want to double check your work, please check out my video on foiling. As always, if you have any remaining questions or if there's a different equation you'd like to see factored, please leave a comment below. Thanks so much for spending part of your day with me. And if there's anything more that I can do to help, just let me know. Thanks so much and catch you next time.